Hello everyone. Welcome back to the channel, Physics Made Easy.
আজকের ভিডিওটা হতে যাচ্ছে খুবই ইন্টারেস্টিং এবং সুপার গুরুত্বপূর্ণ।
In this lesson, we are going to explore one of the most important topics in physics, waves, especially mechanical waves and electromagnetic waves, along with their classification and real-life applications. A wave is basically a disturbance that travels from one place to another, carrying energy without actually transporting matter. This is a very important concept because it explains how energy moves in different forms around us, like sound, light, and even radio signals. First, let's understand mechanical waves. These waves require a material medium to travel, which means they cannot move through a vacuum. For example, sound waves need air, water waves need water, and seismic waves travel through the earth. In mechanical waves, the particles of the medium vibrate around their main position. These waves are mainly of two types, longitudinal and transverse waves. In longitudinal waves, the particle vibration is parallel to the direction of wave propagation, like sound waves where we observe compressions and rarefactions. In transverse waves, the particle vibration is perpendicular to the direction of propagation, such as waves on a string or water surface waves. Now let's move to electromagnetic waves, which are very different from mechanical waves. These waves do not require any medium and can travel through a vacuum, which is why sunlight can reach the Earth from space. Electromagnetic waves are made of oscillating electric and magnetic fields that are perpendicular to each other and also perpendicular to the direction of wave travel. All electromagnetic waves travel at the speed of light in vacuum, which is approximately 3 times 10 meters per second. The electromagnetic waves form a spectrum based on frequency and wavelength. Starting from low frequency to high frequency, we have radio waves, microwaves, infrared radiation, visible light, ultraviolet rays, X-rays, and gamma rays. Each of these has different properties and applications. For example, radio waves are used in communication like TV and mobile networks, microwaves are used in cooking and satellite communication, infrared is used in remote controls and thermal imaging, visible light helps us see, ultraviolet rays are used in sterilization, X-rays are used in medical imaging, and gamma rays are used in cancer treatment. Now let's talk about the applications of mechanical waves. Sound waves are widely used in communication, such as speaking, hearing, and telephone calls. Ultrasound waves are used in medical imaging to observe internal organs and monitor babies in the womb. Sonar technology uses sound waves to detect underwater objects and measure ocean depth. Seismic waves help scientists detect earthquakes and study the internal structure of the Earth. Musical instruments also produce sound waves, creating music that we hear in daily life. On the other hand, electromagnetic waves have even broader applications in modern technology. Radio waves enable wireless communication, microwaves are used in radar and satellite systems, infrared waves are used in night vision and heating devices, visible light is essential for vision and photography, ultraviolet rays help in sterilization and detecting fake currency, X-rays are used in hospitals to detect bone fractures, and gamma rays are used in advanced medical treatments like radiotherapy. Another important part of this topic is the comparison between mechanical and electromagnetic waves. Mechanical waves need a medium, while electromagnetic waves do not. Mechanical waves generally travel slower and depend on the properties of the medium, whereas electromagnetic waves travel at a constant speed in vacuum. Mechanical waves can be both longitudinal and transverse, but electromagnetic waves are always transverse. Also, mechanical waves are caused by particle vibrations, while electromagnetic waves are caused by oscillating electric and magnetic fields. Finally, the key idea to remember is that waves transfer energy, not matter. This is why waves are so important in physics and everyday life. From communication systems to medical technology and from music to earthquake detection, waves play a crucial role in making our lives easier and more advanced. Understanding waves helps us understand how the modern world works, from simple sound to complex wireless communication systems.